Hello everyone, today I present Untitled Optical and Electrical Characterization of Copper oxide Cu obtained by spray pyrolysis and by copper chloride solution for application in renewable energy. The first, I start with my work plan, introduction, work objective, copper oxide CO, application du CO, and definition of spray pyrolysis. After technique of characterization, we have two techniques, the UV technique and the 4 points. Result and discussion, and I end with a conclusion. Introduction. Copper oxide is a semiconductor oxide of type P. It has electrical and optical properties interesting for optoelectronic application, especially in the photovoltaic field. Its optical energy band is 2.14 electrovolts, making it an ideal candidate used in several applications in different scientific and industrial fields. As transparent electrical contact for solar cells and gas sensors. Work objective. The purpose of this paper is to prepare thin film of copper oxide by the technique of pyrolysis spray in discontinuous mode by varying the number of spray and keeping the same molarity. We try to optimize the number of suitable spray to obtain good quality. Copper oxide 2 or copper oxide is a chemical compound of the formula Cu. It is a black solid with an ionic structure that melts around 1200 Celsius and releases a little oxygenate. The copper is in its oxidation state plus to its mineral form. Figure. It is a schematic representation of CO elemental. We can use the CO in various applications such as solar cell, gas sensor, photocatalysis. We have two characterizations. The first is visible UV and the second for this figure. It's a diagram representing the principle of spectrophotometer. And this it's a real UV spectrophotometer image in my university in Ski. The optical gap was determined by applying the TOC model in the region of hot absorption. 4-pound technique. The 4-pound method is a non-destructive technique used to measure the electrical resistivity of a thin film. And this figure, it's a diagram of the 4-pound device. The next figure, it's actual Keithley 2400 meter source. This figure represents a diffractogram of CO films. According to the GCPDS, all the deposited layers show the monoclinic structure of CO with two preferential orientations. And this figure, it's a variation of electrical resistivity as a function of the number of the figure number 9, it's the variation of the transmission as a function of wavelength for different spray. And this figure, represent the mean transmission as a function of number of spray. How to calculate a gap energy? We plot alpha h nu power 2, a function of the energy h nu, and the gap energy is determined by exploiting the linear part towards 0. The last figure represents variation of the optical gap energy as a function of the. A good transparent conducting oxide material can be selected on the basis of two basic criteria: summarizing good transmission and low resistivity. We found that the layer that has good optical and electrical characteristics is the one deposited using 1100 spray, which is the optimal number of spray in our conclusion. In this work, we have developed a series of thin film layers of CO, and we studied the influence of the spray number on the optical and electrical properties. The characterization of the layers led us to the following conclusions. The transmittance values of the CO thin film range from the 65% to 50% in the 900 to 1000 nanometer range, and all the film obtained show high absorption in the visible field. The optical energy band varies between 2 electrovolt and 3.70 electrovolt. The resistivity varies between 0.139 kilo ohm point centimeter and 8.4 kilo ohm point centimeter. The electrical and optical properties improve with the increase of the number of spray, and they will be better in a number of 100 spray. All our film of CO present a strong absorption in the visible field, and they are of type P. Their resistivity varies with the increase of the number of spray, and their gap energy decrease up to 2 electrovolt for a number of 100 spray. That is suitable for the manufacture of solar cell or a gas. Thank you for your attention.